All right, good day again, everybody. Welcome back to Cube County. Welcome back to KodeCamp DevOps. Yeah, it's glad to have you here. We today we'll be going off from what we started talking about in our last class, which was networking. Today we are going to try to build out a network on our AWS platform using the AWS service virtual private network. We'll build out a network, we'll build some subnets in that network and see how all the things we spoke about in our last class, how they work and how they apply to real world infrastructure. Okay. So this is a diagram, a little system design of what we are trying to work with. We're going to build out a VPC and we'll give it this CIDR range of 192.168.0.0/16. And in that VPC, we will have two subnets. We'll have one subnet where we'll have a server, another one where we'll have another server. We'll name them front-end server and back-end server, right? The idea is that the back-end server would only be accessible from the front-end server. And then we will have the front-end server being able to access the outside internet through a NAT translator, which will be running in the internet gateway as AWS provides for us. Then we would also have the backend server also have its NAT gateway for accessing the for accessing the public internet, while still not being able to be accessed from instances from the public internet, but being able to send traffic to the public internet, which is important for when you have services that are running in your backend. You don't want people from outside to be able to access it, but sometimes the need arises where you may need to access resources on the internet. Okay, so very quickly before we go ahead, let's look quickly at some private IP address ranges, because building out a VPC, it's very common to work with the private IP address ranges, which are standard ranges that are created for building out private IP addresses. The first common one is the 10.0.8/8, which has the range of 10.0.0.0 to 10.0.255.255.255. And the next one is 172.16 .0.0/12, and the last one is 192.168.0.0/16, which is the one that we're working with today. From this, you see that it's using the CIDR ranges. This one has /16, and with that CIDR range, only the last two octets are able to be changed, which shows that the last two octets are the host IDs, the host part of the IP address, while this 192.168 is the network ID. So from 192.168, as we can see here, I hope we can see this. Let me just, okay. So I'm talking about this one. So from 192.168, you see that this part doesn't change. And only this host ID part is able to change. 192, that is 16, which it's 32 minus 16, which will give you 16. So only this last two are the host IDs which are able to be changed, right? Okay. So likewise, in this IP where we have /12, we see that that will give us the host ID as the last octet the last octet, the fourth octet, the third octet, and a part of the second octet, which can be changed. So that's why we can have this change here, which has the host ID from a part of the second octet to the fourth octet. While in our final one, we have a which gives us the ability to change the last three octets. It's in here. Okay. So that's what we have on private IP address ranges. The IP address range we'll be using specifically for this course will be 192.168/0/0.0.0/16. And jumping into our AWS console, this is what AWS looks like when you log in. We'll be working with VPCs. We'll create a VPC, which means a virtual private cloud, which is basically your isolated network within AWS where you can deploy your resources and work with your various resources. Once you create an AWS account, you have a default VPC that is assigned to you, which is this one. This VPC, you can then create other VPCs, but if you don't want to create any VPC, if you want to just get on and start working, you already have a VPC that's created for you by AWS, which has this IP address CIDR range 172.31.0.0/16. It also gives you some subnets and all the other resources that you might need. But in our case today, we are going to be creating our own VPC, our own virtual private cloud, which is basically our own network, right? We can name that, we can give it any name we choose to, right? Then we will assign an IP version 4 CIDR range to it, okay? And what we decided to use today, 192.168.0.0/16. Now, if you know how many IP address, how many hosts we can get from this range, this CIDR range, just drop it in the comment section. I'll come back to that later to see how many people got the correct answer. So /16, how many possible hosts can we get from that? Okay, then we will leave everything as default. We don't want to assign an IPv6 block to this network right now. If you want to, you can do that by either using your IP address manager to allocate your IPv6, or you use the AWS provided one, or you create an IP version 6 CIDR range that will be owned by you. But right now we are keeping it on no IP version 6 CIDR block. So we will be working mainly with IP version 4. And we have created our virtual private cloud, right? So now we have a network where we can deploy our resources, deploy our KodeCamp resources, right? So next thing we want to do is to take this is our IP address range as we've used to just create this network right now. If we take this, let's see what we can make of this now. We have /16 here. And like our formula says, we can get the number of possible hosts by using the formula 2 raised to power 32 minus 32 minus our suffix here, right? And that will give us 2 raised to the power 16. Which is the number of possible hosts. So we will have 65,536 possible IP addresses. Possible IP addresses that we can get from this side range, right? Okay. So now, instead of having all this inside just available to us, we want to be able to break this down into various subnets. So what we are going to do is we can decide to work with any side range, for example. We can use maybe /20. /20 is going to give us using the same formula. If you're using /20, let's see, we have S12, and that will give us, okay, we have 4,096 possible addresses. Possible IP addresses that we can get out of this if we use this as a subnet in our our network. If we create maybe 4 subnets, for instance, right? And we add this number, this 4,000 number, we still may not even get up to this 65,000, right? So you see there are many possible IP addresses that we can use in this network. And that's really good because you can assign an IP address in your network to any number of resources you can have. Imagine you're running just for an example, if you know what it is, imagine you're running a Kubernetes cluster and you create so many pods and you need all those pods to have, an IP address so that they can work beyond the network. You see that you have enough IP addresses to assign to them, right? So this network now has 65,536 possible hosts that we can use. For our sub networks, we are breaking them down using /24, right? And this is giving us, we've had this calculation before, but let's do it again. So do that again. We have 32 minus 24. Gives us 8 to raise power 8, which is right, 256 hosts. So the subnets that we are creating, 256 hosts. This 8 is showing us again that's only the last octet. An octet is 8 numbers. So when we have /26 and we have /24, we have 32 minus 24 giving us 8. We can easily know that that's 8. The last octet, the last 8 binary numbers in the octet are the ones that can change, and nothing else can change, right? So, however, in the IP address of this our VPC, we have 2 zeros at the end and /16, showing that the last two octets can be changed, can be used for the host ID. So what I've done here is to create IP addresses in this form, having one of the octets change, that is having one, right? And then having for the host network, say you have a subnet, the sub network having its hosts, its network ID as 192.168.1, and then your host portion of the IP as 0, which can now be changed. And then the next subnet, I'm having the network ID as 192.168.2, which can't be changed for that subnet, right? But 0 can now be changed. Okay, so this is what I'm going to do here. I'm now going to go into my AWS. I'm going to go to subnets, right? When I come into subnets here, I can see that there are subnets already because we had a default VPC that was created for us by AWS, and these subnets belong to that VPC. You can see these subnets, you can see the VPC they belong to, right? This is not the VPC that we created. So we're going to create a subnet now. It's asking us for which VPC we want it to be assigned to, which VPC we want to create that subnet in, and we'll choose our KodeCamp VPC. We will name this VPC subnet 01. We don't put any availability zone preferences for now. This is the IP address. This is VPC CIDR block. And we are going to put in our 192.168.1.0/24. And this has already shown us 256 possible IPs that we can get out of this, which corresponds to what we calculated right here, right? So we have this VPC. We're going to add yet another VPC. And we 192.168, that's 2, right? That's 0/24. Okay. And we create this subnet. Good. Now the next thing we need to create is our route tables. These route tables. What do the route tables do for us? The route tables just specify the different routes in that subnet, the different routes traffic can take in that subnet. Okay. So we can have a route that says right? Another route that says all internet traffic should go to this server. Should go to server 1. Say we have mailing servers here. All internet traffic, if you send any traffic that is supposed to go to the internet, let it go to this server 1. And only this server will have access to the internet. So anything we want to do with outside internet should go to server 1, and server 1 will send that to the outside internet. If you want any traffic, sorry, if you have traffic that is going to maybe all traffic going to one, maybe all traffic that's supposed to go to database, right, should be routed to, maybe we have a DB server, right? We can have another route that says all traffic that wants to go to CodeCamp traffic should be routed to CodeCamp IP. Okay, all traffic that wants to, like things like this, you just specify the various routes, right? So that's what a route table is, showing the various paths that traffic can take and specifying them within your network. Okay, so when you create a VPC, right? If you come to route tables now, see that there's one route table here that's associated. Let's look at our VPC ID so that we'll always have this in our head. Our VPC ID ends with 5E4B. Come to route tables, we see that there's a route table here for our VPC. There's a default route table. Let's look at what we have here. And we see that subnet associations, this route that is specified here, right? This route, remember this IP is our this IP is our VPC IP for the entire VPC. So it's saying that all traffic, all traffic that has the targets as this within this local VPC and has the destination as this can be allowed, right? So all traffic within this IP range, all traffic within this IP range can reach your local network. Okay, so whichever subnets traffic is coming from, as far as it's within this VPC, within this IP range, it can be allowed into your subnet here. Okay, so subnet associations, we see these two subnets as we've created, right? It's being associated with this route table. What we want to do now is have a separate route table for each of these our subnets. Okay, so we're going to go to route tables and we're going to create a route table. We're going to have this route table as right? That's CodeCamp subnet 1 route table. Associate it with CodeCamp VPC and we create that. When we create it, we come to subnet associations and we are going to associate it with KC subnet 1. Okay. We create our next route table. Associated with subnet 2. So now we have our two route tables for these two subnets. Okay. Now, remember we want one subnet to be able to access the internet. Okay. For a subnet to be able to have access to the internet, for a subnet to be able to have access to the internet, it needs an internet gateway, right? So this internet gateway will have access to the outside internet. So any traffic from this VPC that is going to the outside internet, right? We have the IP for public internet is 0.0.0.0. So which means any. So any network outside the range of this IP, right, will be sent to the public the internet gateway that we have here. And this internet gateway then sends it to the outside internet, right? So we need to create an internet gateway and assign it to our subnet 1. Subnet 1 is going to be our public subnet, and we'll have our private subnet as subnet 2. And inside this private subnet, we'll have resources that we don't want to expose to the internet. But in subnet 1, our public subnet, we will have resources that we are okay with exposing to the outside internet. So let's create an internet gateway, right? So creating an internet gateway, we name it, KodeCamp Internet Gateway. It creates the internet gateway. Now, after creating it, we will need to attach it to a VPC, and we will attach it to our KodeCamp VPC. And we have now created an internet gateway that is now attached to the VPC. And in our route tables, okay, let's come to this subnet. We'll go into subnet one. This is subnet one here. We go into subnet one. We come to the route table of subnet one, which is this one. And when we come to this route table, we choose it. We want to edit the routes, right? So we'll edit the routes. We have this our first route that is telling us that all traffic within this VPC can access our local resources. We'll also set this, right? All traffic going to the public, any, right? Is 0000 to the outside internet. Public traffic should be passed through our internet gateway, which is this. And once we add this to the routes, this subnets and the subnet associated with this route table, which is this our public subnet KC01, now has access to the internet. But KC subnet 2 doesn't have access to the internet because there's no routes passing traffic to an internet gateway. Okay. Now, that's what we have there. So, okay, let's take questions after the class. Okay. So our cases route our subnet 2 is still without access to the internet. Okay. So now let's try and create a server within our subnet 1 and another server in our subnet 2. And we will come to an AWS service called EC2, which is Elastic Cloud Compute, where you can create servers and create compute servers. We come to instances, and here is where you create servers. We're going to launch an instance. If any of this is not clear, we are going to explain it as we go along. So we'll name this right? Let's call this our, okay, what do we call it? Front end server. Let's call this our front end server. Okay. Let's take Ubuntu. And a key pair is like your SSH keys that will be created in this server. I don't have any keys right now. So I'm going to create a key pair. I'll name it okay. Let's use the RSA encryption and we create that key. And that has been downloaded for us, okay, into our computer. Then we edit this network settings and make sure that we are creating this in our KodeCamp VPC. And the subnets, we're setting it to subnet 1, which has the internet gateway, which is our public subnet, all right? Also assign public IPs, let's allow that. Create a, okay, let's create a security group, which is basically a firewall for this. where we specify the ports that can allow traffic to on this. So we have a description here. A subnet group is a set of firewall rules that control the traffic for your instance, which is your server. Allow rules to allow specific traffic to reach your instances. So we will name this KC public server security group. Okay. This would, let's allow SSH. Let's allow HTTP as well. Okay. Right. Align SSH from anywhere, HTTP from anywhere, and which is port 18 and port 22. Which other one? I think that's enough for now. Um, okay, so I just enabled an IAM instance role here. Uh, can explain all that in another class. So this is it. I'm going to set up this server now. It's an Ubuntu server. I'm going to launch the instance. Then I'm going to create yet another server. See, it's creating the server. It's still pending. When it shows running, it means the server has been completely created. I'm going to create another server, which I will create in I'll create this in I'll create this in subnet soon. Okay. Um, okay. For this, I'm going to allow SSH traffic from I'm going to allow SSH traffic from every instance that has this security group on it. It's from this KC public security group that we created in the other instance. Right. So SSH traffic from there. And this also would have this IAM instance role, which will give me access to SSM. Okay, it's public too. Okay. Okay. Now I've created another rule here, another firewall rule that's allowing HTTP, that is port 80, HTTP traffic from 192.168.0.0/16, which is HTTP traffic from any resource, any instance within our entire VPC, right? And I will create this server. Okay. It's asking me if I want to create a key pair for it. Okay. Yeah, I'll just use the existing key pair that I've already created. Let's go up there and specify the same key pair that we used for the last instance.
It's selected already. Just launch.
Okay. Just trying to get my key pair. In the meantime, if you look at our EC2 instances, you'll see that this one should have created by now completely. Okay, so we have the front end server running now. Let me start this again. It's loading a little bit too slow. So let me do that again. I have my AC backend server. I'm choosing the OS to be Ubuntu. Select OS, Ubuntu. I'm using T2 Micro, which is free tier eligible. So that's, you know. Then the key pair, I'm choosing the same key pair. Network, and I'm selecting my KC subnet 2. That's the subnets I'm using, right? That's my second subnet, which doesn't have an internet gateway, so it's a private network. Let me see. So I'm now creating my private security group, which is my firewall. SSH. I'm allowing SSH from the public security group. Adding another SSH rule, my HTTP traffic. I'm allowing that from anywhere within my network. Okay. Okay. Um, and I'm going to launch this instance, right? So what we've done, we've created this front-end server, created this backend server in these two separate VPCs, okay? We also have a route table that has been created for them. So now we're going to log into this front-end server. Okay. So for that, I'm going to open my terminal. Right? Should I create a terminal here? Okay. So we have our front end server and back end server running. If you check the back end server, we see that it is 192.168.2.223, right? And we have that as part of 192.168.2.0/24. This is 223. So only the last octet was changed to get this IP. If you check the front end server, you see the IP as 192.168.2.1.223, right? You see that dot one and dot two. Okay. Now we are going to connect to the front end server. Okay. We're going to try to SSH into that. But first, let us try to SSH into the backend server. Remember, we said that this server is in a subnet um with no internet gateway. So traffic from the internet can't come into it. Let's test that out. If we come to connect, we come to SSH clients, right? Come to SSH clients, we can see that the SSH how to SSH into it. It has we have the public IP here. We have the name, right? The name of the username that we're using to connect to it. We have the PEM key. Remember the key we created and downloaded. Okay, we'll use that. Then we'll come to here. I'm going into my terminal now. This is my terminal. I'm going to downloads. I have my Let's see if I have my SSH key in here. I think we named that KCSSH, something like that. Yes, and it's in here. I want to move this into okay. So let me move this key. Okay. So I'm going to go to okay. Now to connect to that instance, right? We're going to use SSH. The identity key will be this key here that we created. Then we're going to How do we get that? This is the public, this is the public IP, right, of the backend server, and we are SSHing into it. If we come to connect, we see that we have how to SSH into it, right? Okay. Going back to our terminal. Okay, so we can see that operation timed out here. So it wasn't able to connect to our backend server. Let's try the same thing for the front end server, the one that is in the public sub. Okay, so let's look at our front end server. Okay, so let's connect to this front end server. The same process, SSH key. Okay, so we just need to change the permissions of our key there. This is also, remember to change the permissions of our key using this change mode. We got an error. Let me, okay. So we got this error here, bad permissions, because the permissions of our key is 644. So we're going to change that. Okay. And we try to log in again. And we are now inside that machine that we just set up. You see here that we have Ubuntu IP 192.168.223, which is the IP of this front end instance. Where is the IP? This is the IP here, 192.168.1.223. So we are able to get into our front end instance because it has an internet gateway attached to it. Okay. But our backend instance, we are not able to get into that one. What's this is exactly as we've seen here. So you can get traffic from outside traffic from the front from to the front end server, but not to the backend server. Okay. Now we also set up. Let's try to SSH into the backend server once again from the front end server. You come to connect, come to SSH here. We don't have this key. So let me see. Okay. So I'm going to copy that key pair and I'm going to paste it in here. You can see that there's nothing in here. Okay. So where am I? I'm in the home folder of Ubuntu. So I'm going to cut um the key pair name. There's a way to do this using SCP, which is SSH copy, but we're not going to do that. We're just going to create this key as the public key. I'm going to stop sharing my screen to do that copy because I don't want to share the details of that key. Then I'm going to copy that and paste it. So now we have this key in here. Let's try to connect to our backend server. That's still not working. Okay. So this is going to time out. Let's try and make a little change here. Come to instances, we come to security groups. Oh no, let's take it from here. The back end, we're in the back, looking at back end now. Let's come to security. Let's look at the security group of this back end. Right. It's allowing 80. Let's see if you can add. Okay. Let's try to make this. Okay. Ooh, can't edit it. Can't edit it. Okay. Let's cancel that. Nation timed out. Okay. I'm creating another security group here that will allow SSH traffic from to from anywhere 192. So okay. See, allow SSH from public subnets. We are attaching this to a KodeCamp VPC, of course. This is SG. Okay. And so our backend instance. Okay, that's what else we have. What's PHC? HTTP from instance. I'm going to try to change the security group. Okay. Okay. So this has two security groups attached to it now. Let's take another quick look at that VPC. We have let's see the routes table. Okay. Let's connect the NAT gateway to this subnet too. AWS can receive traffic from outside. Come to NAT gateways here. If you create a NAT gateway, attach it to our second subnet. Okay, so just to do a quick rundown of what we have done so far. We've created the VPC. We've created the VPC, we've created the first subnet and the second subnet, and we've made this first subnet public. So we are able to connect to it from the outside internet. For the backend service, we are now trying to connect to the backend service. And we've set up the NAT gateway. to be able to connect to that. So what we are going to do is to use SSH to connect to this backend servers now, since we have set up the NAT. Hello, can you hear me? Okay. Sorry about that. I was muted. Okay, so if you have any questions so far, I can take them now while we look through this. Okay. One question. Go ahead.
Hello, good evening, class. Hello.
Hello, good evening. I can hear you.
Okay,
Please go ahead.
so yeah, I wanted to ask the question when you set up the internet gateway, and what I needed to know is the access we are giving or the connection to the internet, is it egress or ingress? Or is it both?
It's both of them. So you can, through the internet gateway, you can send traffic out. You can allow traffic into the network as well. That's subnet as well. Okay. Hello. So
Thank you. I got
the
what you said.
internet gateway allows both ways. The NATs, on the other hand, allows you only to access only from within the network to outside. It doesn't allow from outside into your network. Okay. There's someone else. Please go on.
Okay, sir. Good evening. My question is, when you were trying to do SSH, the terminal you opened, did you open it on AWS or did you open it from your local device?
Hello, please go
Sir,
ahead.
I said it,
So
when you opened the terminal where you wanted to run the SSH, did you open the terminal on your AWS or from your local device? Did you get the question? Okay. My other question is this. I noticed that the two it's offline and online. I noticed that the two instances, EC2 instances you created them from the same availability zone. And I want to know, must they be in the same availability zone? These are my questions.
sorry, could you take it again?
Okay, sir. The first question I was asking, the terminal you opened, did you open it from AWS or did you open the terminal from your local machine? Then when you were
It was from my local machine.
okay, which command line did you use?
The terminal. Now just open my terminal and try to access it from there.
Okay. So my second question is this. I noticed that when you were creating your EC2 instances, you created both of them, both the front end and back end, in the same availability zone. And I want to know, must they be in the same availability zone?
No, they must not be in the same availability zone. The availability zone are different. See them as different data centers within the same region, right? So you can decide to spread out your resources in different data centers, right? To allow for high availability so that you can remove a single point of failure so that if one resource goes down, it doesn't have to affect the rest. So if you're planning for best practices, you should set them up in you should try to use more than one availability zone, right? But for this we're just trying to see how it works. We're just testing. So that's why I set it up in one availability zone. If I was building this for a more critical infrastructure, I will probably set it up in more than one availability zone. Yes. So it depends on what you're trying to do.
Okay.
Physically.
I asked because he's talking about front
Okay.
end and back end. So I was thinking probably they are meant to be in the same availability zone since they are more like a pair. You get, that's why I asked.
Since what?
Since they are more like a pair, they work hand in hand, front and back. That's why I asked.
Okay. The front end and back end, if you're creating it, you should create the front end server in one availability zone and the backend server probably in the same availability zone. Okay. That's one is now a question of latency that you're trying to resolve. But spreading it out for high availability, they should be in more than one availability zone. Okay.
Okay, thank you.
What I set up here, I did not specifically pick any availability zone. I did not pick any preferred availability zone.
Okay.
Okay. there any other question? I don't see any other hand up. Okay, so I think maybe this will be where we'll end the class for today. We will be setting up the AWS in our next class for ourselves, so that we will have our various AWS systems in our where we can work with. Okay. Okay, so thank you everybody. Bye.